You have a powerful multi-core CPU, yet your program struggles to process data. We are unlocking the secret to Java parallelism and how it can make your code 10x faster. There is a story: two developers, single-threaded Sam and multi-threaded parallel programmer Peter. Meet Sam. He builds a stock price prediction system using traditional single-threaded Java code. And the result is application lags, crashes, frustrates users. Now meets Peter. He optimizes his code using Java parallelism because he has experience already. His program is 10x faster and processes millions of stock transactions effortlessly. What is the difference? Sam's program is stuck in the past, running single-threaded while modern CPUs is working, which have multiple cores. But Peter, on the other hand, unlocks the full power of Java parallelism. Let's break it down so even a 10-year-old can understand. What is the problem? Why modern CPUs demands parallelism? Imagine a pizza shop, that is the analogy, where only one worker chef is making pizza while 10 others idle, and you have lot of orders. So orders are piled up and customers are waiting in a queue. So business suffers. But if all 10 workers prepare pizzas simultaneously, the orders will be fly out at lightning speed. There will be no queue and you are right now then wasting your power. So let's fix that. Java is providing a game-changing solution, that is a parallelism. The first one method, parallel streams, which are effortless parallel processing. If you want an instant speed boost, parallel streams are your best friend. In this code, we are showing the details. If you break down, Java automatically splits work across CPU cores available in that machine because it's a depends. No manual thread management needed here. Faster execution happens, task running in parallel. So example, output fork, join, pull, which are main methodology are used behind the scene. So what is the warning in this parallelism? Parallel streams are not always perfect. This method I am talking about. Not ideal for small dataset like thread overhead, which slows down, and avoid where the ordering, like sorting applications where order matter. Parallel execution is not sequential. That's why ordering are not happens properly. If you want more control, let's go deeper. Method 2, executor service, which is fine-grained thread control. Parallel streams are automatic, but what if you need precise thread management? Here is how executor service gives you full control through this code I am explaining you. Actual key benefits: managing the thread pools efficiently, controls how many threads are running, prevents CPU overload by limiting the threads. This is the example output. But what if you need non-blocking operations? You need to jump on the method 3, that is the asynchronous processing. So completable future, imagine ordering a pizza. You don't want to stand in a queue and complete the cooking process. You want to continue watching Netflix till the time order is made. So here is how Java do the things asynchronously in this code. It is a detailed stock prediction system code. I have shown it here. Why? Question is why completable future, non-blocking? Because its program is keeps running while waiting for data, handles multiple tasks simultaneously, and it is great for APIs, stock prediction, tradings, apps, real-time systems like IoT devices. So in this code, how this actually working? This actually fetches Apple and Tesla stock prices in parallel and does not block the main thread. Users can keep trading. Scalable, handles thousands of price requests at once. So what is the final showdown? Who wins in this situation? Sam's single-threaded Java programs 5 minutes to process 1 million records, but that is huge. Peter's parallelized program 30 seconds that time. Moral of the story: if your Java programs don't use parallelism, you are wasting CPU power and slowing down your applications. Did this story help you understand Java parallelism in a new way? Please subscribe our channel, share this video with your friends, like this video, drop Java parallelism in the comment section if you want more real world programming tips. If you want to join with our regular Java and other programming batches, please contact us. Thank you so much. See you in the next session.